Alright, welcome back to chapter 3. We're going to start talking about the coordinate plane and lines. Before you can graph lines, you got to learn how to graph points. And the main thing to know about the coordinate plane is that the coordinate plane has an x, y axis. Sometimes it's called the coordinate plane, and honestly, sometimes we just call it the xy axis, just to say that we're graphing in those two dimensions. But the idea is that every point we graph on here is going to be an x, y point, where of course, again, x is the horizontal axis, and 0's in the middle, 1's to the right, 2, so on and so forth. Then there's -1, -2, etc. So this x-axis is what we've been using all inside of chapter 2, and we've been graphing our inequalities. But there comes a point where we need a vertical axis, and that of course is our y-axis, where we still have 0, but the positives move up and the negatives move down. So that's our xy axis, and the way we graph a point is, well, we move left or right. Now the one other thing is, just to say real quick, that we call these 4 different sections that are made by cutting, we call these the quadrants. There's quadrant 1, 2, 3, and 4. They make us see in that order. So for the first one, they'll say, hey, plot all these points and then state their quadrant. Now the one last thing to say is, hopefully we remember this, that in the middle here would be the point 0, 0. We call that point the origin, because every time every time you graph a new point, you will be graphing it from the origin. So let's do that. We're at 0, 0. My first point says 4, -3. Remember, they go x, then y, horizontal, then vertical. So if I'm at 0, 0, then I would go right 1, 2, 3, 4. Now hold your pencil there or pen there, and then go down 1, 2, 3, because it was -3. Here's point A. Point A is in quadrant 4. All right. Point B would be left 2, -2, 1, 2, horizontally. Keep it there and then move up 1, 2, 3, 4. And there's point B, which was in quadrant 2. Up next, this one's a little bit interesting. 0, 3 means do not move left or right, but go straight up 3. There's C. Now, which quadrant is C in? Well, it's technically not. It's on the y-axis. So we just label it like that. So you're not on a quadrant, you're on an axis. And then 5, 0 would of course mean go right 0, but then don't move up or down. So that would be on the x-axis. 1, -4 would be right 1, down 4. There's point E. That's going to be still again in quadrant 4. And of course -2, then -3 would be in quadrant 3. Alright, so that's the basics of graphing points. You start from 0, 0, you move your x coordinate first, left or right, negative or positive. Then from that point that you stopped at, you then move up or down, again based on positive or negative for your y coordinate. Now, then we need to ask, what is a line? Now, I won't write it out because I did this on the notes online that, again, you can see posted later. But the line is simply going to be, whatever. I'll fill it out. A line is going to be, let's just write it, the collection of all possible coordinates that satisfy a linear equation. All right, so in other words, a line, even though usually we draw a line from 2 points, the idea is that even that connecting line between is a set of a bunch or millions or really infinitely many different points that have really small, ugly decimal values, or really in between decimal values, but they're still a part of what make up that entire line. They still work. We just wouldn't want to find them ourselves. We'd want technology to find them for us, or we just want the graph to show us that. Now then the question is, well, how can I find coordinates on a line? How can I know what I need to look for? And the answer is there's kind of three ways. There's guess and check. Two, there's, I guess I'll call it set and solve. And three would be called graph behavior. And that's really what we're going to be looking at in this section is how do I do all three of these? So this first example, our second example of 3.1, would be a guess and check, so to speak. So essentially the homework problem, even though it says determine if 9,3 is the solution, it's kind of like saying, hey, here's a random point, right? I'm just guessing that 9,3 might work. Could you plug it in and tell me if it does? And whoops, that should be an equal sign. So could you plug in 9,3 into this equation and tell me if I get a true statement? Well, again, remember that this is a coordinate. This is x comma y. So if I look at my algebra, I would have 4 times 9, because that was in the x position, the first position, minus 10 times 3 in the y position, should be equal to, so when we do this, when we solve and check, we put a question mark over it, just to denote that, hey, I don't know if this is true, and you told me to figure out if it is true. And if I plug this in, that's going to be, well, 36. That's going to be 30. And the question is, does that equal 18? And we can kind of go ahead and stop right there, because 36 minus 30 is 6, and is 6 equal to 18? The answer is no. So is 9,3 a solution to that line? No, it's not. And then, again, the reason this is called guess and check is because then you'd probably go, well then, what is a solution of this line? And you would just try another pair. And honestly, that's going to be time-consuming and not really fruitful or easy. So up next, now we're going to get into the guessing and checking. All right? So what I want to do here is I want to show you that even though you might have some graphing experience, especially on ones like number 5, if you remember slope-intercept form mx plus b, you probably already know what this graph looks like, but we want to build up to what we call, what did I say? Graphing behavior. And we want to start by saying, again, can we just test points out until we find? So this would be the set and solve approach. So what we're going to do is we're going to say let or set x equal to, let's do some number like 3. So if I just say, okay, I'm choosing x is 3, notice that's different from saying, hey, plug in 9,3 like we did in the last one. Take x and y. Well, if I just take 1, then I can substitute that in. Let's see what happens. I get, I'm going to work a little ahead. I get 6 plus y equals 10. Hopefully you see that again, if I plug in 3, 2 times 3 is 6, so that's now 6. There's still a y there, and I'm still equal to 10. Well, at that point, all I need to do to get y by itself is subtract 6, and I get 4. And so the set and solve method is pretty cool because I just chose 3 out of nowhere, and I got 4. And so look, I now have a point 1, 2, 3, 1, 2, 3, 4 that I know is on my graph because I was able to set and solve. Now, you want to be careful because not every time you do this is it going to work out nicely. And so let's force that to happen early on just to see it. And let's say that I want y to equal 3. Well, let's set y equal to 3 and what happens? Well, if y is equal to 3, I still have my 2x. I now have a plus 3 equals 10. And if I work that out, that's 2x equals 7, which means x equals 7 over 2. Now, that means I do have the point 7 over 2, but 7 over 2 is a fraction. So even though I found a point, 7 over 2 comma 3, I might not want to graph that. And so you'll need to be careful about kind of the numbers that are multiplying around here. And there is still some, I guess, guessing and checking until you find a nice pair that works. But you actually can graph 7 over 2 comma 3, but we'll still just choose another question. or another point. Let's say we want x to equal 0, and we'll come across this again later. But if I let x equal 0, actually, this still isn't quite too useful to me, because I would end up getting, right, if x is 0, 2 times 0 is 0, and I would just have y equals 10, so I've got the point 0, 10. The issue with that one is, hey, that's above where my graph even is. You know, your online tool will even only go so far, so so far, it's still a little tricky. It's better than guessing and checking. Maybe let's try one other. Let's try let x equal 5. If I let x equal 5, well, whatever, I'm technically guessing. Whatever. If I let x equal 5, that's going to be 10 plus y equals 10, and I end up with y equals 0. I wasn't trying to find the zeros, but it happened anyways. Okay, finally, 1, 2, 3, 4, 5, comma 0. I've got another point on my graph. At that point, I could connect them and I'm good to go, but I think what's more important, and especially because of the sections coming up, is let's take a minute and look at these points. These 2 points, if I wanted to connect them, I should be able to go down 4 and write 2. Or if you can think about it, since both of those are even numbers, I should be able to go down 2 and write 1, down 2 and write 1, down 2 and write 1, and this goes on forever and ever and ever, and I start seeing all the, I guess, not perfect points, but nicer points I could have chosen along the way. And even this one right here, like if I follow this up, this graph goes up to 7, so this is the point 1, 8. And if I follow that up and I go left, I'm now at 0, and I go up 2, I'm now at 10. So hey, look, there's the point 0, 10 that I found. It was just off the page, and now I can kind of correctly graph where that should have fallen. Now again, you didn't need all 10 of those points, you just needed 2. Now here's one other thing I want to point out. 7 over 2 is 3.5, so if I go right 1, 2, 3 and a half, and then go up 1, 2, 3. There's that point right there. It is on the graph. It's just an uglier point. And that's what I mean again, is that a line is a collection of all these points. We're just specifying or almost highlighting, in a sense, the ones that I know will work nicely, but any of them will work nicely. Now, I know my graph looks pretty ugly the way I drew it, but remember, you're going to be doing this online with a graphing tool, so that's okay. Let's go through this guess and check process one more time, just to introduce it and get used to it, and then maybe we'll start looking at some graphing techniques, because really this whole, not guess and check, but set and solve will only take us so far. So once again, let's say let x equal, honestly a nice easy one here would be 0, and we're kind of getting to a point early on, a few pages around. But if I let x equal 0, 1/3 times 0 is just 0. That's super nice. Y is just -2, and there's my point, 0, -2, and I'm done. 0 down 2, there's point number 1. So 0 is usually a nice choice because it leaves just the other numbers. It just depends on if that leaves the other number really high off the page or whether you can actually use it. In this case, I could. So there's one set and solve done. Now, here's the hard part is I need to find a number that's going to work nicely with this 1/3. Maybe like x equals, 3, but I don't know, let's just do something else. Let's do 6. Because 6 will still work. 6 times 1/3 is 2, and 2 minus 2 is 0. Gosh, I keep accidentally finding the intercepts. Alright, you'll end up with 6, 0. So there's 6, 0. Now same thing, let's think about the pattern here. I can go up 1, 2 and write 6. If I can go up 2 and 6, I could also go up 1 and write 3. So let's just even confirm that. Evidently I should have the point 3, -1. Let's do that. Let's say let x equal 3. And that would be at that point y equals 1 minus 2, which, yep, is -1. So at that point, again, there's my line. I don't need to find all of them. I just need to find a few and solve. All right. Up next, let's look at number 4. Number 4, this is a special form, or actually number 3 and number 4 are special forms of lines. We call them standard form, when you lead with x and then you have your y and then you have your number on the other side. We call that standard form. We'll talk about that more in another section, but I just kind of want to introduce this vocab because hopefully a lot of this is a little bit of review. But what I want you to notice about standard form and what we're going to talk about below, we'll kind of almost spoil it because it's happened already. Determining intercepts is when we set x equal to 0 and solve, spoiler alert, that's the y-intercept, and when we set y equal to 0 and solve. Oops, sorry, that was off the page. That would be the x-intercept. So notice there that if you want the y-intercept, x must be 0. If you want the x-intercept, y must be 0. It's set the opposite thing to 0 to get the thing that you want, the intercept that you want. And in fact, this has happened a lot. Incidentally, you can see it. I let x equal 0 and I found the y-intercept 10. And then I didn't do it the quite order, but it happened anyways. I let x equals 5 and I got y equals 0. I could have done that in reverse. I could have said, let's make y 0, and then I would have found that x is 5 at that occurrence. So that's just an easy way to go through those problems, and I want to expose this early on because 4 is a great example of this because look at this, 4 and 3 easily divide 12. So this general form is great for finding intercepts, and especially when your numbers are divisible with that number on the other side. And so let's see that now. So let's just say, let's let x equal 0. If I do that, 4x will be 4 times 0. That'll just go away. I'll have negative 3y equals 12. I can divide the negative 3 and I get negative 4. So great, I just found my first point, 0, negative 4. If I graph that, that's right here. That is going to be my y-intercept because it's on the y-axis. All right, let's do the opposite. Let's let y equal 0. So see what I'm doing there is I'm doing it once for each of them. X is 0, solve. Y is 0, solve. Now if y is 0, the 4x stays, but negative 3 times 0 disappears. I still have 12, and look at that, I get x equals 3. So now I have the point, careful about the order, 3, 0, x goes first, then y. So 3, 0 is right here. And now I've found my line, and that didn't take too much effort. So determining intercepts, it's super easy in what we call standard form. Again, I'm kind of jumping ahead, but we'll see this in more examples anyways. Now let's look at 6 and 7 because these are special. We're going to graph them on this same axis, but these are special because, well, these don't look like the lines we were just looking at beforehand. These are each special because there's only one variable. And so the key here is these are horizontal or vertical lines. So far, every line we've had here has had either a negative slope or a positive slope. They've had a slant to them when we've graphed them. But not all lines have a slant. Some of them are special, and their equations look special as well. My key, or my trick for you here is, my little phrase is, the variable you see is the, I guess I don't need a comma there, is the axis you cross. Alright, so it's super easy to graph these once you memorize this fun little sentence. So again, there's a y-axis, there's an x-axis. My first equation, number 6, says y equals 3. So I'm going to cross the y-axis. If I'm crossing through this axis, how do I cross through a vertical axis? Well, I must be horizontal. And where am I going to be horizontal? Where am I going to cross through this axis? Well, at 3. So here's 3 on the y-axis. Here's me crossing through it. There's line number 6. And then similarly, if I want to cross through the x-axis at negative 2, here's my x-axis. Here's negative 2. I want to cross through it. This is line number 7. Now you might be a little confused as to why that's the case, but I think this explanation will clear it up for you. Hey, this is the point, if we go back to graphing, 0, 3. Well, what's this point? This point is the point 2, 3. What about this point? This is the point 6, 3. This is the point 7, 3. This is the point negative 5, 3. Do you notice something about every single point that I say about this line? The y coordinate is always 3, which is why this is the line y equals 3. It's the line where every y value is 3 and your x value doesn't matter, so to speak, because no matter what x you plug in, y is 3. That's why there's no x in this equation, because the x, doesn't matter what you plug in, you're always getting 3. You're a horizontal line. Same thing for 7, just a little bit of a different argument. And at that point, we got 2 more questions, and that'll be enough for 3.1 for the day. It's similar questions. We want to find the intercepts and graphs. So sometimes when your online homework asks this, just be aware that they're saying, hey, I actually need the 2 points that you plot, they can't be whatever you want. I need the x and y intercept. So let's practice our set and solve again. If we let x equal 0, we'll be left with negative 2y equals 8, because again, 4 times 0 will just disappear. That means we get y equals negative 4. So I've got the point 0, negative 4. There's my y-intercept. If I set and solve again, if I let y equal 0, then let's see here. 4x stays. The other one disappears, and I still have 8. And I get x equals 2 when I divide. Again, I'm just saying it out loud. Notice that we go quicker and quicker through the simple algebra from chapter 2 because hopefully it is getting simpler and simpler as we practice our homework. Alright, there's my y-intercept, 0, negative 4. Don't move left or right, go down 4. Here's the other one, go right 2 and don't go up or down. There's my line graphed based on intercepts, even though, again, I could have used technically the point 1, negative 2. I could have used the point 3, 2 if I had drawn that better. 4, 4, so on and so forth. You get the idea. A line goes on forever, and that slope that we'll learn about later in just a little bit is always the same no matter what 2 points you find. But again, they specifically asked for the intercepts in this case. Alright, up next, let's look at this last one. This one is where it's not as easy to find the intercepts because, well, we're not in general form. We are, although, in slope-intercept form, so this coordinate right here is the y-intercept, but let's see why that's true. If we let x equal 0 to find the y-intercept, now notice also as I was going through this, I wasn't saying let's solve the y-intercept and the x-intercept, because honestly, I think it gets confusing because it's, the reverse. You let x equal 0 to find y, you let y equal 0 to find x. Sometimes we just get confused. You should really just think at some point I'm doing it for both, and I'll figure out which one was which when I graph it. So, again, I'm finding the y-intercept, but you don't need to know that at this point. You just need to know one of them 0 solve, then the other 0 and solve. And then maybe at some point we memorize which one is which. But if 0 is plugged in here, well, ugly fraction times 0 is still just 0. And so y is just 4, because that whole thing goes away. And so, yeah, this is the y-intercept, 4. That's, of course, why this is called slope-intercept form, because it's sitting right there in the equation. Now, this next one might be a little bit not as pretty. If we let y equal 0, then I've got negative 4/3 x plus 4. And if I want to get x by itself, I'm going to need to subtract 4 to the other side. And I'm going to have to multiply by the reciprocal by negative 3/4. And actually, maybe that's not too bad because the 4's cross cancel, the negatives double negate. And so I actually end up with x equals 3. So I've got the point 3, 0. All right. So, guessing and checking, so to speak, is definitely the worst way. The next best way is setting and solving. Now you can technically choose whatever number you want, unless they say please find the intercepts. Otherwise, feel free to plug in anything until you get a solution that works. That's enough for 3.1. I'll see you in the other sections.